I am your narrator, Rudral Oza, with the further slides. The topic I will be talking about will be future and directions to use of AI in health informatics and healthcare. And we are starting with precision medicine. So now what is precision medicine? It means treating patients with the same it instead of treating patients with the same targeted therapies that are being done right now. Treatments are more customized based on their individual profile. And the most driving factor for the rise of popularity of precision medicine is, as you guessed it, AI. And this includes several factors like genetics, lifestyle, past medical history, and even environmental exposures. What AI helps us here is it helps us shift through millions and millions of data points to match a patient with the most effective treatment. For let's consider a real life scenario. Like right now in cancer therapy, AI systems can analyze a person's DNA mutations and predict which drugs are most likely to work. Several drug trials have already made use of AI to identify patients who respond better to targeted therapies. This not only helps us improve the outcomes, but also drastically reduce the side effects. Since patients don't waste time on treatments that aren't likely to help them. Moving further, we talk about integration of the said huge data and help of AI in genomics. Now, what is genomics? It means it is the study of our DNA. And AI has a really powerful application here. But there are certain problems to the application while we have some solutions while we are also searching for others. Genomics has the potential to reveal why some people are more vulnerable to certain diseases than others. Thus, it has created these sad problems. First, privacy. Privacy is a major concern of ours. A person's genetic code is the ultimate personal identifier, and if leaked or misused, it could lead to serious consequences such as genetic discrimination, misuse of the said information to target others. Second, the cost of sequencing DNA and building AI models around it is still very high and expensive, which makes it difficult for many healthcare professionals in hospitals or countries to adopt. Third, underrepresentation in datasets is a serious issue. Most genomic studies are based on European populations, which means other groups are underserved or misrepresented. This could cause unequal healthcare outcomes. And finally, interpretation issues also exist. Even if AI detects a genetic variation, we may not know whether it truly causes a disease. Doctors can't always act on AI predictions unless they are clinically valid and explainable. Fortunately, some of the solutions are emerging to the to address these set problems. For privacy, as we talked about, genetic data can be protected with stronger encryption, secure storage systems, and stricter laws like GDPR or HIPAA, which are starting to be implemented in some of the said countries. To reduce costs, governments and international organizations are investing in large shared databases and cloud computing, which lowers the barrier for hospitals and research labs. Tackling biases require building more diverse genomics datasets. This means people from different ethnicities, regions, and health backgrounds can use this set data and upgrade and update it. So AI models benefit everyone equally. And for interpretation issues, as we will talk about in further slides as well, explainable AI is still being developed and is in the phase of being a rapid is in phase of being in a rapid development. These systems don't just give predictions, they also show why a mutation is linked to a condition. Genetic counselors can then work alongside AI to guide patients properly. With these improvements, AI could become a key driver of personalized medicine in the future. Moving further, we go on about ethical and explainable AI. As we talked about in last slide, what really is explainable AI? We'll get to know about it in this slide. A major concern in AI in healthcare is the black box problem. While you guys may not know what black box problem is, it just means many AI systems generate answers without showing how they reach them. And it is a very, very important concept of understanding the why behind the equation. Imagine that an AI is telling a doctor that a patient has a high risk of heart failure, but not explaining why. The doctor would hesitate to trust it. This is where explainable AI or XAI comes in and is so important. It makes decisions transparent. For example, if an AI predicts heart disease, it might highlight factors such as high cholesterol, smoking habits, or family history. This helps doctors validate the decision and give patients confidence that AI isn't just guessing. Here, ethics also matters. If AI is trained mostly on one group of patients, it can be biased against others. Fairness in training data is essential as well. There's also the issue of accountability. If AI makes some mistakes, who takes responsibility? The doctor, the developer, the hospital? Clear regulations are needed here and clear hierarchy needs to be set up. Government and health organizations are pushing for updated rules so that AI in healthcare is safe, fair, and transparent moving further. We talked about how AI can be helped, how AI helps in doing it. But the key component in in AI in healthcare booming is collaboration. For AI to truly transform health informatics, collaboration is key. Doctors bring medical expertise, AI developers bring technical skills, and while policymakers set the rules, without all three working, progress will stall. This is why it is a key component for AI to boom in healthcare and help progress. Another important point in training healthcare professionals, doctors, nurses, and technicians need to understand how to use AI tools, interpret their outputs, combine them with clinical judgment. It's also important to stress that AI will not replace doctors. Instead, it will act as an assistant, handling repetitive tasks like analyzing scans or summarizing patient histories, while doctors focus on empathy, decision making, and patient care. With responsible use, AI can ensure fairness, trust, and safety. In conclusion, AI is no longer a futuristic concept in healthcare. It is truly reshaping health informatics today with ethical and responsible use. The future looks very promising. Thank you guys. That was my time. I hope you guys have a very, very good day.